Recently, NASA made a startling announcement. The space agency hinted at a potential contact with extraterrestrial life 47 years ago, for a brief 72-second period. But how is that possible, and what exactly did they make contact with? What really happened 47 years ago from now? That could change the life of mankind. Before we begin, make sure to subscribe to our channel. It really motivates us to do better. Let's take a journey back to 1937. Reber, an American amateur astronomer, invented the first working radio telescope. Reber was the first to map the Milky Way's radio structure and find bright radio sources outside our galaxy. His observations later helped physicists uncover a new type of radiation called non-thermal radiation. Now, imagine radio waves as light waves. They're both part of the electromagnetic spectrum and zip through space at the speed of light, which is a whopping 186,282 miles per second, or 300 million meters per second. The Project SETI, or the search for extraterrestrial intelligence, has been dedicated to scanning the vastness of space for these radio signals, hoping to pick up a hello from advanced civilizations. And one day, on August 15, 1977, something truly extraordinary happened. The Big Ear Radio Telescope at Ohio State University's Perkins Observatory picked up a signal, which was remarkably strong, narrow, and lasted for 72 seconds. The man who discovered it, Dr. Jerry R. Imminent, was so amazed that he circled the data, analyzed it, and wrote, "Wow," on the printout, being utterly impressed. And that's how it got its name, the WOW signal. But what made the WOW signal so special? It was detected at 1,420.4 megahertz, right within the hydrogen line. This is a specific radio wave frequency that hydrogen atoms emit, acting like a unique fingerprint around 1,420 megahertz. Many scientists think this could be a potential channel for extraterrestrial communication. For 40 years, the WOW signal puzzled astronomers. In 2017, Professor Antonio Paris suggested that it might have come from comets 266P/Christensen and 335P/Gibbs due to their hydrogen gas clouds. But not everyone agreed. The signal was brief and didn't repeat. Plus, the Big Ear Telescope's dual feed horns should have picked up a comet signal twice, but that didn't happen. While Emin isn't convinced it's alien, the WOW signal remains the strongest signal ever received from the outer world, and its origin is still a mystery. Fast forward to 2020, a signal from the heart of our galaxy, the Milky Way, caught the attention of scientists. This signal, thought to be a galactic center radio transient, GCRT, was picked up by Australia's ESCAP radio telescope. Out of 2 million objects sending out signals, one unique source in the Milky Way's core stood out. It sent out 6 signals over 9 months, each with an irregular pattern and polarized emissions, invisible in other spectra. Despite months of careful monitoring with 2 telescopes, this signal played a cosmic game of hide and seek, disappearing and reappearing a year later, only to vanish again within a day. They could be neutron stars, pairs of pulsars, or fading pulsars sending out erratic radio signals. A new telescope, the Square Kilometer Array, might help solve this mystery. While there's no concrete proof yet, there's a tantalizing possibility that we might be receiving signals from advanced civilizations. But that's not all. In another intriguing discovery, an object that has been emitting radio signals since 1988 is located 15,000 light-years away. These signals recur every 20 minutes, varying in intensity, and last up to 5 minutes. Initially, scientists thought these signals were from a magnetar, known for its intense magnetic fields. While the idea of extraterrestrial origins is exciting, history advises us to be cautious. The first pulsar, initially dubbed LGM-1, Little Green Men 1, turned out to be a natural phenomenon. Pulsars are currently the prime suspect for the mysterious signal, which fades in intensity until they stop emitting radio signals. However, researchers found an object similar to a pulsar but rotating much slower, ruling out this explanation. Another possibility is an ultra-long period magnetar, a rare type of neutron star with strong magnetic fields capable of energetic bursts. Yet, this object emits radio waves every 22 minutes, unlike known magnetars that release energy more frequently. But what was it really? Again, we're waiting for technological advancements to give us a definitive answer. Finding radio signals from far-off civilizations depends on many factors. First, we need to tune into the right frequency, ideally between 1420 and 1662 MHz, though others might be used. Strong signals are vital, either through high power or precise aiming. Signals weaken over distance, so they need to be strong enough to reach us. There's a time limit too. Aliens must send signals when we're advanced enough to receive them. Despite space's enormity, our signals have only traveled about 200 light-years, reminding us of the vastness of the universe and the time it takes for light to travel. That's where the alien communication becomes tricky. Take Sirius, for instance. Its light takes 8.6 years to reach us. So, what we see now is actually 8.6 years old. Sometimes, we see light from stars that are older than humanity itself. Now, imagine what if aliens get our messages, but by the time they reply, we're already gone. How they communicate is still another puzzle. Groups like Breakthrough Listen are listening for alien signals, hoping to hear something by 2029. But our radio signals might not be understood or noticed. So, maybe staying quiet is our best bet in reaching out to them. Scientists are speculating about alternate ways of communication as well, such as using optical signals, which are powerful light sources like lasers. They can also send focus signals across space, possibly indicating intentional communication, although they're still limited by the speed of light. Or sending automated spacecraft to other star systems, similar to Voyager 1 and 2, that could establish contact or relay information. Or neutrino communication, which means neutrinos that pass through matter without any interaction, could theoretically transmit messages over vast distances. But it requires extremely high-tech modulation and detection system. Or gravitational waves, which the advanced civilizations might utilize for communication by creating detectable events, capitalizing on our newfound ability to detect these waves. Or encoded DNA or microbes, where messages could be encoded into DNA, either within engineered organisms or those already present on a planet, albeit a more abstract approach. Or stellar manipulation, such as altering the appearance or output of their star, like intentional dimming or brightening, could serve as a signal of their existence. Or, finally, megastructures, which means constructing large structures like Dyson spheres that could not only benefit the civilization but also serve as beacons to others. Some people think we might be able to use quantum entanglement to send messages to aliens, but right now, that's not possible because there are some things about it we still don't understand well. If humans met aliens, it would change everything. Either we'd be too overwhelmed with updates, or we might face significant problems like aliens invading Earth, or changes to our environment and health. Our beliefs about religion and life might also change hugely. But meeting aliens in 2024? It's important for advancement in science, space, and technology. So, what do you think? Are we on the brink of a historic discovery? Or is there more to the story? Share your thoughts in the comments below. And remember, subscribe to stay updated on this cosmic journey. Thanks for watching.